Today we're going to be talking about lesson 6.5, part B on percent error. A percent error is the percent that an estimated quantity differs from the actual amount. So this is when we're talking about the true right answer and an estimated amount. So for number 1, it says Jessie estimates the weight of her cat to be 10 pounds. The actual weight of the cat is 13.75 pounds. Find the percent error. So in order to find the percent error, we first need to find the amount of error. So we're going to subtract our two pieces of information. We are going to take that difference, the answer to our subtraction, and divide it by the actual amount. So here we see that the estimate is 10 and the actual amount is 13.75. So we put 13.75 as our denominator. When we subtract 13.75 and 10, we end up with 3.75 divided by 13.75. Now keep in mind that that top number, or the numerator, goes inside the division. Now, as we do this, we can see that we're going to need to move the decimal 2 places to the right. So we have 1,375 can't go into 3, 37, or 375. It can go into 3,750 2 times. So 2 times 1,375 is 2,750. When we subtract, we end up with 1,000. We then bring our 0 down. So we are now looking at how many times can 1,375 go into 10,000? It can go into 10,000 7 times. So 1,375 times 7 is what you should be multiplying right now. As you multiply that, you should have ended up with 9,625. We can then subtract 10 take away 5 is 5, 9 take away 2 is 7, 9 take away 6 is 3, and 9 take away 9 would be 0, and bring that next 0 down. Now we can see here that we're starting with that 3,750 again. So we can see that this is going to have a repeating pattern. We can go ahead and bring our decimal point up to the 4 places after the decimal point. Go ahead and finish those out for you here. Now, we need to find the percent error. So unless otherwise specified, always round to the nearest tenth of a percent. So we change the decimal to a percent by moving it 2 places to the right. And when we go to round, we look at the second place behind the decimal, and the 7 tells us to get bigger. So it is approximately a 27.3% error. As we look at number 2, we can see that each week Mr. Jones goes to the grocery store. Mr. Jones estimates that he will spend $120 when he goes to the store each week. He actually spends $94. Find that percent of error. So again, we're going to subtract our two values. And we're going to divide by the actual amount, which in this case is 94. 120 take away 94 is 26. And 26 will now need to be divided by 94. 26 goes inside the house. 94 can't go into 2 or into 26, but it can go into 262 times. That's 186. We can then subtract to get 74 and bring down a 0. 94 can go into 740 7 times. 94 times 7 is 658, which will give us 82. Again, bring down another 0. 94 can go into 820. It looks like I actually had a small error here. Let's go back and take a look. So 7 times 94 would be 188. So let's see if that will change our answer at all. So 7 times 94, 2 times 94, 188. 10 take away 8 is 2. And then 25 take away 18 is 7. Bring down our 0. Now, 94 can go into 94 can go into 720. That's 7 times, which will still make that 658. When we go to subtract here, 10 take away 8 is 2. 71 take away 65 is 6. Bring down a 0. So 94 can go into 626 times. 6 times 94 would be 564. We can then subtract to get 56. Bring down that last 0 that we're going to need to round to the 10th of a percent. 94 can go into 565 times, and that would be 470. Now, we can bring that decimal point straight up. So we have 0.2765. Again, go ahead and try to change this to a percent by rounding to the nearest 10th of a percent. You can see that we're going to need to move the decimal 2 places to the right to get 27.65%. Rounding to the nearest 10th would give us approximately 27.7% of error. Now, let's go ahead and try number 3 on your own. As you've set up the problem, we're going to subtract our two amounts. 300 minus 230 is 70. Divide that by the actual amount of people, which is 300. When we divide 70 by 300, we get 0.2333. Now again, try to change that to a percent and round to the nearest 10th of a percent. Here we have 23.33%. The value in the second spot behind the decimal is a 3, which tells the 3 before it to stay the same. So our percent of error will be approximately 23.3%. Now, when we're talking about estimating and percent of error, we're finding the amount that by how much our estimate was wrong. So if we're trying to make good estimates, our percent of error for our estimate will be lower. The higher percent of error will mean that our answer or our estimate was more incorrect.